Now, prior to do that, okay, unfortunately, if you are not happy with your thermodynamics, okay, if you are not happy, hopefully you are not, because we will use those thermodynamics, especially the entropy and enthalpy, in this chapter. Okay, so be good with your thermodynamics. Okay, now let's review. This is the ideal gas law. Anyone do not know what is it about? Okay, so this is the ideal gas law where you can get your density from the pressure R and T. If you are looking at the advanced thermodynamic book, usually it is written, right? This one is the M, right? The number of, or this N is the original form is PV-nRUT. This is the universal gas constant. Okay, so if you divide this universal gas constant, because this one is giving you molecular number, and you know your M is equal to right, gram per mole, right? Okay, so that's why you can change this one into M or whatsoever that rho, right? M or rho. M. So you change this one into M. If you change this one into M, this RU has to be divided by M. Okay, that's why you get M over V is rho. Okay, so that's where you get it. So those are, okay, if you don't pay attention, don't cry during the exam. That's it. Don't ask me. As simple as that. Okay, you laugh now, you cry later. You cry now, you laugh later. I can guarantee you that. Okay, so R there is the constant or gas constant, specific gas constant. It is specific for each gas. It is not 8.31 blah blah blah. No. That one is universal gas constant, but this one is specific gas constant. Whenever you have R there, it is specific gas constant. Another thing is, you pay attention here, the pressure is the absolute pressure. You cannot use gauge pressure. Okay? One more thing, the temperature is also absolute temperature. If you are using Celsius, you get it wrong, don't complain to me saying, oh, I do not know, sir, so I'm using Celsius. That's your problem, not my problem. Right? So always use the absolute pressure and the absolute temperature when you are using this ideal gas law. Okay? Now, if you do not like your thermodynamics, I just give you brief kind of energy that is involved in your thermodynamics. You have the internal energy. When you are talking about the internal energy, you have molecular translation, molecular rotation, vibration, electron spin, nuclear spin, and so on. All of those, if you want to calculate one by one, you can do it. Yeah, with all respect, you can do that. It's doable, right? But usually, we will just combine all those things, become U, internal energy, right? Okay, and if you look into that, you have thermal, mechanical, kinetic, potential, electrical, magnetic, nuclear, anything else that I missed? Right? And all of these things is called a microscopic energy. Okay, if you want to learn about it, you open the book entitled Molecular Thermodynamics. Okay. How do I know? Because I take one course on it. So if you are looking into the thermal, you have sensible and latent heat. Sensible energy is the thing that creates temperature difference. If you boil a water, you take water at 20 degrees C, you put it on top of a fire, then the temperature will increase from 20 into 100. That one is sensible energy or sensible heat. After it reaches 100, usually at 180 atm, it will start to boil. When it boils, there will be a phase change. Doesn't matter how big you open your gas, right? It will not increase the temperature of the water. Doesn't matter. Okay? Once it reaches those boiling temperature, it will just phase change. Okay? Until the water dry out. When the water dry out, it will start to increase the temperature of the kettle. Not the water. The water already gone. Okay, so how do you get the higher temperature for that? You keep it pressurized. You keep it pressurized, you can achieve a higher temperature. Okay, that is the reason why if you cook your chicken using water, right? If you fry your chicken using water and if you fry your chicken using oil, of course vegetable oil, you do not want to put lubricant oil there, right? You will get a different texture. Why you get different texture? Because oil, yes, at higher temperature. It boil at higher temperature, which means it can reach higher temperature. When it can reach higher temperature, the destruction of the amino acid is different. That's why you got this brown, crunchy skin. Okay, but inside those skin, actually you still get the same, right? The same white meat. Okay, I know you haven't had your lunch, that's why I tease you with that. Okay, so that's sensible heat and latent heat. And if you are talking about internal, it's actually taking into account sensible, latent, chemical, and nuclear. Okay? So we don't care about that. At the end of the day, we just care about this. If you have a fluid within a bucket and you investigate the fluid, you call it a fluid static. But when we are talking about thermodynamics, when you have a stationary fluid, the energy of those fluids is called internal energy. Because there is no work flow. Still remember what is work flow? Work flow is the work due to the flow. Right? Sometimes you call it PV or you can call it P over C. You remember what is this V? This V scratch is not velocity. It is a specific volume. Volume per mass. We got this as a volume. So this small thing is specific volume. So it's meter cube per kilogram. Okay, specific volume. Okay. Now, if you have moving fluid, you will have U, which is the internal energy. You have the flow work. You have the kinetic energy. And you have the potential energy. right? So unfortunate, you have these two also. This kinetic energy is because you have the movement, you have the velocity, and this one is because you have a different in elevation. These two, usually in thermodynamics, you will combine it into H, enthalpy. Right, this one is your enthalpy. So if you combine, it becomes H v square over. Okay, if in your thermodynamics you hit entropy, unfortunately you will meet again in this course. Okay, you know this is your change of entropy, which is dq over T. And you know that there is no way entropy can be reduced. You can only increase it until when our world is at. Right? Basically, you are also contributing to the development of entropy every single day. When you turn on the fan, when you turn on the lamp, when you turn on your engine, every single thing you do, actually you generate entropy. And there is a prediction if the entropy is generated too fast, such that after some time you may not be able to use your internal combustion engine anymore, right? Because the internal combustion engine can work. You have to have a different in temperature, right? Your engine temperature has to be this, your surrounding temperature has to be that. Can you imagine if somehow our environment is as hot as hell? Right? If your environment is so harsh like the one in Mars, so that if you turn on the engine, doesn't matter what, because the temperature is the same, it will not work. Because there is no temperature difference. When there is no temperature difference, you know, your source and the sink is at the same temperature, this thing will not be there. You know, for thermodynamics, right? Thermodynamically, if your sink and your source is at the same temperature, there is no work will be generated. Okay? So be good with the nature. Okay? If your environment is as hot as hell, there is no way you can turn on your aircon. Right? So, okay, you know that entropy will always be positive or zero. Okay, if you have a zero, then it is called isentropic process. An isentropic process is usually called adiabatic when there is no heat exchange, reversible, right? Which means you can reverse, but it's almost impossible. Almost impossible. You pour a water, you have a water in two different locations. Okay, you open the water through a channel. In this channel, you connect it with the turbine, right? This turbine generates electricity. You store it in a battery. Okay, now all water goes to the lower reservoir. Do you think the energy stored in this battery will be enough to put it back there? Yes, because it is not reversible. So you always generate entropy. Okay? By right, you cannot. Okay, only for a very specific condition you can keep it zero.